Have you ever wondered what really holds great software together? I mean, it's not just the code, right? It's something invisible, like a blueprint, and that's its architecture. This is probably the most critical decision in any project, and believe me, getting it right or getting it wrong has huge consequences.
So let's talk about something we've all probably seen. You start a new project, everything's clean, simple, beautiful. But fast forward a year, and it's an absolute nightmare to change anything. You try to fix one tiny bug, and suddenly 3 new ones pop up. Yeah, that's not just bad luck. That's a classic sign of a much deeper problem.
And that problem, more often than not, lies in that invisible foundation. What you're looking at here is what we call a big ball of mud. It's a system with no real recognizable structure, and it's exactly what happens when you neglect architecture from the start. Making changes becomes slow and painful, testing is a mess, and trying to scale it, forget about it. This doesn't just create technical debt, it absolutely kills a team's productivity.
So, how do we untangle all this? Well, here's our game plan. First, we're going to nail down what architecture actually is. Then, we'll see why it matters with a pretty dramatic story. We'll learn the one law that governs everything, understand the modern role of an architect, and finally, we'll talk about how you can start thinking this way too.
All right, so first up, what exactly is software architecture? It's one of those terms we hear all the time, but the definition can get surprisingly fuzzy. Let's try to clear that up right now. At its core, architecture is all about those fundamental structures. You know, the really big pieces and how they all connect and communicate. A great analogy is a skyscraper. Think about the foundation and the main structural beams. They have to go in first, and once they're in place, changing them is incredibly difficult and expensive. If you get those wrong, the entire building is at risk.
And that leads us to a really key distinction: architecture versus design. You can think of architecture as the what, the big picture, high-level structure, and design as the how, the nitty-gritty, lower-level implementation details. But here's the most important part. This is not a one-way street where architecture dictates everything. It's actually a continuous cycle. The architecture guides the design, but the challenges you uncover during design often force you to go back and evolve the architecture. They absolutely have to work together.
So, what actually happens when that foundational structure is flawed right from the get-go? To really feel the cost of an architectural mistake, let's step away from the keyboard for a second and look at this powerful cautionary tale from way back in the 17th century. So, picture this. King Gustavus Adolphus of Sweden, once the most powerful, most intimidating warship the world has ever seen. It was a hugely ambitious project. The ship was supposed to be both a troop transport and a heavy gunship, a combination that, at the time, nobody had ever really pulled off. And here it is, the critical architectural flaw. To show off Sweden's power, the king insisted on stacking 2 full gun decks with these massive heavy cannons. This was a radical change from the proven, stable, single-deck designs of the era. The shipbuilders were apparently pretty nervous about it, but who's going to argue with the king?
The result? Complete and utter catastrophe. On its very first voyage, with huge crowds cheering from the shore, the Vasa sailed less than a mile. Then, a light gust of wind hit the sails, and because the ship was fatally top-heavy, it just rolled over and sank right there in the harbor. Its flawed architecture made it unstable by its very design. It's really the perfect metaphor for a software project that collapses under the weight of poor foundational decisions.
The story of the Vasa, as wild as it is, reveals an inescapable truth about all architecture. Whether you're building ships or software, there are simply no perfect solutions.
And this brings us to what's known as the first law of software architecture. It's simple. Everything is a trade-off. Every single choice you make has a downside. And if you ever think you found a solution that has no downside, it just means you haven't found the trade-off yet.
Let's make this real. Take a look at this simple auction system. When a new bid comes in, how do you let all the other parts of the system know about it? Well, on the left, you could send a direct message to each service through its own dedicated queue. Or, on the right, you could publish it to one central topic that they all listen to. There is no single right answer here. One might be faster, but the other might be more reliable or easier to add new services to later. The architect's job isn't to find a perfect answer. It's to analyze these trade-offs and pick the best one for this specific system. Okay, so if it's all about analyzing these complex trade-offs, who is the person actually making these huge decisions?
This brings us to the modern role of the software architect, which, let me tell you, has evolved a lot.
You can just forget that old idea of an architect sitting in some ivory tower, drawing up rigid blueprints and handing them down from on high. That model is totally broken. Today, a successful architect grows out of tight, continuous collaboration between the architect and the entire development team. It's a relationship that has to be built on leadership and mentoring, not on commands.
So the bottom line is this: an architect's job is to guide, not dictate. They're the ones who have to analyze the trade-offs for every major decision. And just as importantly, they have to be able to justify those decisions to business stakeholders and negotiate them with developers. They are the guardians of the system's long-term health, which really means they're protecting the team's ability to keep shipping features quickly.
Now here's the thing. This way of thinking, this architectural mindset, it's not just for people who have architect in their job title. It is a skill that makes every single developer better at what they do.
This pyramid of knowledge explains why. At the very top, you've got the stuff you know. Simple enough. In the middle is the stuff you don't know. But the biggest, most dangerous part is that foundation, the unknown unknowns. These are the problems, the new requirements that nobody on the team sees coming. A solid, flexible architecture is your #1 defense against them. It gives you the ability to adapt when the unexpected, inevitably, happens.
And all this leads to a final, wonderfully pragmatic piece of advice. Don't ever try to create the perfect architecture that solves every hypothetical problem you can dream up. That's a trap. That's how you end up with over-engineered systems like the Vasa. Instead, your goal should be to find the least worst architecture, the one that elegantly solves your real, current problems while you consciously accept the trade-offs you have to make.
So the big takeaway here is that architecture is all about balance and foresight. It's that deep thinking that stops our software from turning into that big ball of mud. And so I'll leave you with a question to chew on. What is the most important trade-off that you're facing in your project right now? Thanks for tuning in.